This video, we're going to solve applications that involving compound interest. So these are going to be like credit issues, loans, and maybe some investments. So the first thing is going to be a CD, a certificate of deposit. So Marcus receives an inheritance of $1,000. That's going to be his principal. He's going to invest in a 12-year certificate of deposit, a CD. So my time is going to be 12 years. And the CD pays 7%. 7%. And that's compounded monthly. So how much will Marcus receive when he redeems the CD at the end of the 12 years? P times 1 plus R over N to the NT. So A is going to be $1,000 times 1 plus 0.07 over 12 to the 12 times 12. Let's figure that out. 1,000 times 1 plus 0.07 divided by 12. And that's raised to the 144th power. It's going to be 2310.72. So Marcus made $1,310.72 over 12 years. He more than doubled his money that way by investing it in a certificate of deposit that was a long-term investment with a pretty good interest rate there. So that was a sound financial investment there to double his money if he didn't need it for 12 years. Karen Gaines invests $10,000 in a money market account. So that's just another type of savings account that is for large amounts of money where they have market exposure, usually that the bank invests it for you and it gets a better interest rate with an interest rate of 2.75%. So that's 2.75% like that. And it's compounded semi-annually. And 3 years later, Karen wants to withdraw the full amount to put towards down payment on a new house. So how much is Karen going to withdraw from the account? So let's see what the accumulated value is, assuming that she doesn't touch the account for 3 years. 10,000 times 1 plus R over N to the N times T. Point 0.0275 divided by 2 raised to the 6th power. And we get $10,853.88. So you see that didn't quite do nearly as well as the CD did. So the interest rate wasn't nearly as high, 2.75% on the money market account, as opposed to the 7% interest rate on Marcus's CD, even though Karen invested 10 times as much money. It just didn't grow nearly as fast because it only compounded semi-annually instead of monthly, and it had a much lower interest rate. All right, so let's go ahead and look at one more problem here. Brent Pickett borrowed $7,000 in principal from his brother Dave. He agreed to repay the money at the end of 3 years, giving Dave the same amount of interest that he would have received if the money had been invested in a 2.25% compounded quarterly. So basically, this is Dave's taking the money out of probably a savings account where it would have been sitting there earning interest, and Dave says to Brent, you can borrow the money, but you're going to have to pay me back with interest at the same rate that the bank would have paid me, so that I don't lose value on my money that was sitting in the bank, because it was going to earn interest. That's lost earnings to me if I just give the money to you and it's not sitting in the bank, so you need to pay me back that same amount of interest. That's pretty normal for an arrangement between family members like that. So how much did Brent have to repay his brother? So 7,000 times 1 plus, this is 0.225 over n to the n t, and this is going to be 7,000 times 1 plus 0.0225 divided by 4 raised to the 12th power, and I get $7,487.40 is what he's going to is what Brent is going to have to pay back to Dave by the end of the 3 years. So next time we're going to look at something called effective annual yield that has to do mostly with the stock market and bonds and things like that. That we look at something called yield. So we will talk about that next time, and see you for that next video.